In our second tutorial, we will divide polynomials using long and synthetic division and factor and find roots for a polynomial function. So let's flip over to this page of our notes. We're going to be looking at two types of division, polynomial long division and polynomial synthetic division. Before we actually look at either one of those, I'm going to go back to a problem that you did back in elementary school. We're going to divide 1242 by 9, and we're going to go through the process of long division with that. So if we're going to divide 1242 by 9. Of course, we're making our problem look like that. And we ask ourselves a question. We ask, how many times does 9 go into, well, it can't go into 1, so we look at the 12. How many times does 9 go into 12? And we say that it goes in 1 time. And that answer goes up top here. And then we multiply this number by this number and put that right here. And then we draw our line and we change our sign because we do need to subtract. And we get 12 minus 9 is 3, and then we bring down everything else, 342. I'm going to switch colors. And then we go again. 9 doesn't go into 3, but we ask how many times does 9 go into 34? And it goes in 3 times. So we go 3 times 9 is 27. And then we draw our line and we change our signs and we subtract. 34 take away 27 is 7, and we bring down whatever's left, a 2. We change color one more time. And we ask ourselves again, how many times does 9 go into 72? And we say it goes in 8 times. 8 times 9 is 72. We put that there, we draw our line, and we change our sign, and we realize that this is 0. So if 9 goes into 1242 138 times and has a remainder of 0, then it is important for us to understand that 9 is a factor of 1242. Because 9 divides evenly, there is no remainder, then that must mean that 9 is a factor. 9 times 138 is 1242. I show you that simple problem so that we can look at the steps that we used for it and follow along when we do polynomial long division. Now we're going to take this trinomial, this quadratic, and divide by x minus 2. So it's very similar. I'm going to put the x minus 2, the thing that we're dividing, into the quadratic, and then the quadratic will go underneath this little division symbol, I guess. And that's how we set up our polynomial long division. Now it's similar, but it's not exactly the same. So follow along here. We take our x, just the first part of whatever we're dividing in. We just take the x and we ask ourselves, how many times does x go into the first part of what we're dividing into, 4x squared? How many times does x go into 4x squared? Well, an easier question is, what do I need to multiply x by to get 4x squared? I would need to multiply x by 4x to get 4x squared. So how many times does x go into 4x squared? 4x times. And I can check that by multiplying back. I'm going to multiply back the 4x times the x and get exactly 4x squared. But I also need to understand that since there is a second part, I do need to distribute. So the 4x times the negative 2 is going to be negative 8x, and I'll put that in my next as my next term. And then I draw my line and I change my signs. When I draw my line, I change this positive 4x squared to a negative, and I change this negative 8x to a positive. I like to change my negative signs into positive signs with sort of like a little slanty one, so I know that it used to be a minus sign. Or obviously you can use a different color. This first thing will always cancel away. If it doesn't, you've done something wrong. And then I'll combine my like terms here. Negative 15x plus 8x is negative 7x. And then I'll bring down anything else that's left, this positive 10. And now I get to go again. I take this x, and I see how many times does x go into negative 7x? Or rather, what do I need to multiply x by to get negative 7x? And the answer is negative 7. And then I distribute backward. Negative 7 times x is negative 7x. And negative 7 times negative 2 is positive 14. When I draw my line and change my signs, the negative turns into a positive. This positive, I have to scratch that out and turn it to a negative that way. This will always cancel away, otherwise I've done something wrong, and then 10 take away 14 is negative 4. I can try and go again. I can see how many times does x go into negative 4, but that just doesn't work. So that means that we are finished. And unlike this problem where we ended with a 0 so that we knew that it was a factor, this did not end as a 0. So that means that this x minus 2 is not a factor. So that's important to understand. When you have a remainder of 0, the thing that you divide it into is a factor. If you do not have a remainder of 0, then you've either done something wrong mathematically, or the thing that you're dividing into is not a factor. X minus 2 is not a factor. So here's polynomial long division. I'd like to show you that one time. Polynomial long division will always work. I want to show you synthetic division because we've come up with synthetic division. It's faster, it takes up less space, and I dare say it's easier. But you do have to understand how to do it. So my synthetic division, I'm going to set it up for the same exact problem. I put a little box here and then a line here. And that's all it's going to take. It's going to take a line of space here, a line of space here, and then a line of space here. That's all the writing that we're going to do. Now, if we're going to do this exact problem again, x minus 2, synthetic division, we take away all of the variables, basically. So x minus 2 is what we're dividing into, or dividing into the quadratic. The number that would correspond with this supposed factor is a positive 2. Remember, if the factor is x minus 2, I know this isn't actually a factor, but if this were a factor, then positive 2 would be its corresponding 0. So that's the first thing you have to understand about synthetic division, is you're not using the factor or the questionable factor, you use its corresponding 0 or root or x-intercept. So that's the first thing. And then we're going to take the polynomial that we're dividing into and take its coefficients. So 4 and negative 15 and 10. And I'm just going to write them right here. 4 and negative 15 and 10. And that's all that we need to do for our setup. Now watch me. Don't copy as I go because it goes so fast. Just watch me do this. The first step is we drag this coefficient down across the line and it still stays as a 4. And then we multiply. 2 times 4 becomes the 8, and then we add these numbers together and get a negative 7. And then go again. 2 times negative 7 is negative 14, and then we add these two numbers together and get a negative 4, and we're finished. Now that you just saw it, maybe you blinked, let me do it again. We drag this first coefficient down across the line, and then we multiply here and put that answer here, and then we add, and then we multiply here and put that answer here, and then we add. I always like to put a little line right here because that separates what I what I have from my remainder. This 4 used to be a 4x squared. Once it goes past the line, it decreases by 1 degree and becomes 4x. This was the linear term, had the x with it. Once the number goes past the line, it loses that term, so it's just negative 7. And then this is our remainder. We write our remainders as something divided by the thing that we were originally dividing by, and that's what we have. And that's exactly what we had over here. You see the 4x minus 7. Here's the 4x minus 7. You see that we had a remainder of negative 4, and what we probably should do with that is write it as the remainder. Negative 4 over x minus 2. And now we have our exact thing. We can see that that goes a whole lot faster. It takes up less space. And the numbers are very similar. So if we had the choice, I would much rather do synthetic division. So I'll go ahead and circle that. That is our answer. Let's do another synthetic division problem. Let's divide, here's f of x, 3x cubed plus 7x squared minus 4, and let's divide by x plus 2. Of course, we could do our long division, but I'm going to choose synthetic division. Now, as I'm reading this, my eyes saw something missing, and you have to be careful, especially with synthetic division. If you know that a term is missing, you must note that it's missing because synthetic division needs a spot for every coefficient. I can see that we have our cubic term and then our quadratic term, but then we skip all the way to our constant term. We're missing our linear term. There must be a 0x in there somewhere. So when I'm doing my division, first of all, let's set it up. There's that. I need to make sure that I have a spot for everything. So if x plus 2 is going to be the factor, I don't know if it's a factor or not. Let's assume that whatever it is, I know that negative 2 would be the 0 that would correspond to x plus 2. Okay, so it's always that opposite idea from factor or supposed factor to root. And then I have to spill out my coefficients. I know that there's a 3. I know that there's a 7. I know that there's one missing, so I have to put a 0. And then I have the negative 4. And now let's go. Let's do our synthetic division. We drag this 3 down across the line. We get 3. We multiply and we get negative 6. And we add 1. We multiply and we get negative 2. And we add negative 2. We multiply and we get 4, and we add and get 0. It's always nice to end with the 0 because that must mean that x plus 2 is a factor. X plus 2 is a factor. If x plus 2 is the factor, now we know that negative 2 is a root, is a 0, is a solution. Oops. Is a x-intercept. Big distinction between these two. The x plus 2, the thing with the variable, is your factor, and I know that because the remainder is 0. That means that negative 2, remember the opposite idea, that's our root or 0 or solution or x-intercept. Now let's see if we can interpret our answer, these numbers that are below the line. Remember, this 3 used to be the coefficient of a cubic term. Once it goes past the line, it loses a degree and becomes the coefficient of a quadratic term. The degree 3 turns into a degree 2. It's called depressing the polynomial. And then we just go down our degree. So if this is 3x squared, then this is going to be just plus 1x. I won't put the 1. And then minus 2, our constant, excuse me. And then we don't have a remainder. So that is what's left when we do our division. So we have two important things. Let's start with the factor theorem. A polynomial f of x will have a factor x minus k if and only if f of k is 0. So meaning that if our factor is x minus k, if we put k into this little box and we do our synthetic division and it results in a 0, that means that f of k is 0. Therefore, k is a root and 0 and solution and x-intercept, and x minus k is our factor. And one final key concept, if we are given a factor or a root to a polynomial, we can use that in synthetic division to find all other factors. So let's say I asked you to factor this cubic. You do not know how to factor many cubics unless it's a difference of 2 cubes or a sum of 2 cubes, or if we could do grouping. And this is not any of those three things. But we can still factor. I give you something that could be a factor. You prove that it is a factor. And then we can take what's left and factor that. And let's do that in our next thing. I'm going to take all of this, copy that, and let's paste it into our final example. Well, it's the same example, but just part B. So here is our same thing. If you want to copy that down, that's great. Why don't you pause the video and do that? So it says find all factors and all roots for our function. So we already put the -2 in here. We did our synthetic division and we ended with a 0. That means that -2 is one of our zeros, one of our roots. And we depressed our cubic down to this quadratic. Well, now we can factor this quadratic, because we should be able to factor any quadratic as long as it's factorable. I'm going to split apart the 3x squared into 3x times 1x. I'm going to split apart the 2 into 1 times 2. I like that there's only a few options here. I'm going to go ahead and put my parentheses. I know that 3x and 1x will be in the fronts. I know that the 1 and the 2 will be in the back, but I don't exactly know where it will be yet, so I'm going to change color and act like this is a guess. I'll just go ahead and put the 1 and the 2 and see where I am. I know that my signs alternate, so I'll just throw in a plus and a minus. I don't know what's going to happen. Let's see. This is 1x, and this is -6x, and that adds up to -5x, and that's not at all what I want. So my number is wrong. I will switch my numbers. So it's not 1 and 2. Let's try 2 and 1. Let's see what that does. Here's a 2x. Here's a -3x. That adds up to -x. That's so close. That's exactly the number that I want, just the wrong sign. So that means I switch my signs. It's not plus minus. It must be minus plus. This is -2x. This is +3x. That adds up to +x, which is exactly what I want. So now I have all of my factors. F of x. We already knew that x plus 2 was a factor because that corresponds to my -2. So I'm going to say here's my x plus 2. And then I just factored the rest of it into these two factors, 3x minus 2 and x plus 1. So I just factored f of x. Here are my factors. If I wanted to find my zeros or my roots or my solutions or my x-intercepts, remember there's 4 names for all of these things. I know that this first factor would correspond to a -2. I know that this second factor would correspond to a +2/3. And I know that this third factor would correspond to a -1. So I can do my factors, and I can do my roots, zeros, solutions, x-intercepts. So thanks for watching that on synthetic division. We'll practice our synthetic division. It's really fast and really efficient, and I hope that you understand that. We'll practice more in class. Thanks for watching. See ya.